countries and a citation count of over 2,000. His contributions are globally recognized. Currently, he is a manager at a TVS Motor Company focusing on high voltage electric vehicle safety. His work is shaping the future of electric mobility and sustainable transport. So we are excited to learn from him today. Let us welcome Kannadasan sir to begin the session. Thank you.
Thank you, Ibrahim sir. So it was my pleasure to share my experience today, and thanks for the great introduction given for me.
Thank you, sir.
I'll go for the presentation. So actually, now I cannot share my screen, sir. Ajay, sir.
Try, sir. Now you can try. 1 minute, sir. Yes, sir. Now you can try, sir.
No. Okay. Okay. Good.
Thank you, sir.
So very good morning to everyone present here. As Hanraj told about me, so myself, Dr. Kannadasan. So I don't want to stress the time again to introduce my past records. Okay. So at present, I am working at a TVS Motor as a manager for lead advanced technology developer for future mobility. I am part of the Academy for Product Development and Technology Excellence at TVS Motor Company. So today the topic which we have taken for discussion is high voltage system and safety for electric vehicle. So it was a last time rush by RJV. That's why. So we have limited discussion today because this is an unplanned session. However, I will try to manage maximum level of my potential towards the topic. Okay. So let me go with some introduction about high voltage because we know about high voltage for power system and electrical side, which we are aware about that, but we're for a transmission system. Then what is the difference between the high voltage system for a power system and high voltage system for electric vehicle means there are a lot of differences, lot of things we have to concern, particularly in terms of safety precautions. So e-mobility voltage classes. First, we have to know about the voltage classes given by the standards, particularly the globally recognized standards called ISO. There are some standards also available as IEC and ANSI is also available. But the most recognized and well stabilized thing is ISO. Okay, I think you know about the ISO standards. So we have two kind of codes for e-mobility voltage classes. Both are recognized by the ISO only. One is ISO 6469 class 3 and followed with ISO 67221. So these two standards will suggest the voltages for e-mobility. So we are having two different cases for AC and DC. I think we know about that. The e-mobility uses both power supplies or blend of both AC or DC or combination of both. For example, we can say that means if I'm going to use the BLDC motor for a voltage beyond 60 volt means, of course, beyond 60 volt it is called high voltage e-mobility. But the full is it is a full of DC because from battery charging to inverters, everything is fully DC up to motor BLDC also having a pulse DC only. So it is full package of DC supply. And other cases we are having if you are going for super premium vehicles or high performance vehicles, of course we have to go for a different motor specification. Particularly, I can say if you go for a PMSM, permanent magnet synchronous motor means. Of course, we have to use the blend of AC and DC because, of course, we have the battery as a DC source. Then we have to use the inverters. From inverters to PMSM, we have to convert DC into AC. So this is a blend of both AC and DC. And sometimes we have a lot of complications of using both cases, because blend of both will create a new problem to the engineers to resolve the safety concerns. So as per the standard, we can have the three classes: 1A, 2, 3B. These are the three voltage classes generally accepted by the industry and also recommended by the standards. But the problem is the voltage classification given for AC and DC is not equal because of various reasons. We will discuss the reasons behind this in the future slides. So when we can say this is a low voltage e-mobility means if the voltage is below 30 volt for AC, or if the voltage is 60 volt below for DCs, we can say this is a low voltage class e-mobility vehicles. So for example, now we are having a lot of vehicles we are using for scooters. Not a bike, not talking about bikes. If you are using a scooter, for example, Ola, TVS, Ather, Hero, they are using the vehicle. They are always prefer to go for low voltage only. For example, I can say that TVS uses 48 volt to 52 volt, and Ola uses 56 volts. So these are the voltage generally the industry are choosing because the representation of the standards always prefer to go with the limitation of voltage only. Why means if we increase the voltage beyond the 60 volt means then the designs, safety, modules, and some other additional parameters, lot of things they have to incorporate in the design section. This will lead to the modeling of the electric vehicle for higher cost. Because we have whatever the product we are performing in the industry, that has to be accepted by the market, because market is the leader, customer is the leaders, they have to accept that. So the product should be both performance good and as well as the cost effective. So if you increase the voltage rating beyond some value means, of course, the cost of the vehicle will be very, very huge. So it will be very tight task for the industry to deliver the product to the customers. That's why these some of the known industries are using low voltage as per the recent trends. But in future, low voltage vehicles will not perform in the market good, because the global market looking into the high voltage vehicles only, because they are looking for high performing vehicles. That's why we have to go for high voltage vehicles. But the problem is, while we go for high voltage vehicle, what is the problem with the safety concern to the rider as well as the consumers? So this is the general classification of voltage. Follow with the high voltage. High voltage class number 2, representation of AC voltage less than or equal to 600 volts and up to 900 volt of DC. These are the voltage band for high voltage for class 2, and high voltage for class 3B, representation of 1000 volt for AC and 1500 volt for DC. So whatever the discussions, whatever the presentation, the maximum volt for e-mobility as per the standard is 1500 only. We cannot design the vehicle by using the voltage more than 1500 voltage. It's not possible. It is highly impossible. It is against the policy, against the standards. So the maximum voltage can be used by the e-mobility is 1500. That is the representation or recognized by the standards. But how they are using means, is there any specific voltage vehicle has to use means, there is no specific scales the industries are having. Between that 1500, between that 60 volt to 1500 volt considered as a high voltage, between that they can use the any scale of voltage required by the design engineers. There is no specific rule to use 1000 or 900 or 800. We can use whatever the voltage, but that should be within the recommendation of the standards given by 6722 class 1 and 6469 class 2. So we already seen the presentation. The AC voltage is 30 volt, DC voltage is 60 volt. Why this kind of disparity shown to the AC and DC means there are some reason. The problem is the AC source triggers more current than DC for same voltage due to time varying nature and the capacity behavior of human body. We are not thinking about the performance of the vehicle in the terms of AC or DC. But if the electric mobility or EV vehicle exposed to any accidents means, of course, there will be the human inside the vehicle. And what is the a threat to the humans while the vehicle exposes the electric current to the body of the vehicle. Okay, so human body is the source now. Okay, so we are considering about the human body, but the problem is human body, as we know that we are thinking that human body is a pure electric conductor, but it is totally a false statement. Human body is a insulator first, then only we are taking it as a conductor. Okay, because the human body will act as a capacitor only. Okay, so for example, I can say that we are having the example for a parallel plate capacitor. We are having a two conductor, and one conductor we are as using the power to energize. Other conductor will be idle only. Between that, we are having air as an insulating medium. Okay, of course, we are in the meaning of electrostatic condition. We are Sir, can you hear me now, sir?
Yeah, clear.
Ajay,
Sir, slide is now moving, sir. Same slide now.
oh, same slide.
Yes,
Just wait,
sir.
just wait, sir.
Yes, sir. Sir, it shows can't share your screen, sir. So you can try, sir. Because I'm not
Just wait,
sure
just wait,
anything. Yeah.
just wait. I will do. I will do.
Or you can share with me, sir. I will share.
Just wait, sir. I send the PPT to your WhatsApp, sir. You can share by yourself, sir, because I can't share the file here.
Share, sir. I will share. I will share.
Yes, sir. You can go for next slide, sir. Sir, did you see that presentation slide for the past hours?
So the slides are not visible, sir.
I think he left out. Ajay, sir. Yes, sir. Yes, sir. I can see that. See the presentation. You can go for next slide. I think, hope you can now see that voltage classification which we discussed pastly. Okay, so these are the voltage classes as I mentioned on the discussion. We're having a low voltage, high voltage class 2 and high voltage class 3B. So the voltage classification is between 30 is the AC. It's called below 30 it is called low voltage, and up to 1500 volt we can say it is a high voltage cases. So the most of the vehicles are presently in the market are low voltage vehicle only, because they're using 48 to 56 volt only. So low voltage vehicles are we are using that, maybe TVS, as I mentioned, TVS is called iQ, and Ola we are having a S1 Pro and S1X for example, and we have a lot of models also available, Ather, Hero, etc. So all the vehicles are using low voltage system only, because the voltage is less than 60 volt for DC only. They never go with the AC motors. So these are the classification recommended by the ISO 6722, 64, 69, as I mentioned on the previous hours. Sir, you can go for next slide, sir. So why the AC voltage is lower than DC voltage? Because the low voltage cases less than 30 is the 30 volt is the low voltage, but for the same thing for a DC 60 volt as a low voltage. So what is the disparity? Why this has been taken place means there is a two main cases. AC or DC, the victim is the humans. Okay, so we have to think about the human body behavior, human shock behavior. Or we can say it's a physics of human body. So considering the physics of human body only, we are classifying the AC voltage as a minimum or low voltage as a 30 and DC for 60 volts. The reason is one thing, AC triggers more current than DC because it's a time varying quantity, and also human body is a capacitive by nature, because human body consists of a skin at the outer part of the surface. Human skin is purely insulated. It's called the term is called keratin. So keratin is a purely insulator. So keratin will act as a shield to human body. Okay, but internal part of the human body consists of blood vessels, glands. These are purely conductive material, conductive compounds. So if the current is injecting on the human body through skin means, of course, skin is a keratin, consists of a insulating medium, but internal part is a gland, consists of conductive medium. So this will act as a two parallel plate capacitor configuration. So this AC source will trigger more current through the capacitive mode of human body than the DC. That's why DC is limited to 30 volts. But AC is limited to 30 volt as a low voltage, and for the same thing we are going for the DC is the 60 volt for e-mobility for DC thing. We have the chart for the claim in the future slides. We will discuss the chart clearly. Okay. So due to this fact only, all the standards are recommending 30 volt and 60 volt as a high voltage for AC and DC mobility, as we mentioned. Okay. So, but why 30 volt? So not, you can go back, sir. Yeah. Why specifically the standards are recommending 30 volt for AC and 60 volt for DC means, as I mentioned, it's purely based on the left go current of the human body. Okay. So of course the human body is the responder, because they are going to act as a victim in this scenario. So we have to think about the let's go current value. So the let's go current value is not equal for DC and the AC, as I mentioned in the previous discussion. Why we are using the AC and DC, how it is varies. Okay, so the let's go current is differ for AC and DC. That's why we have to go for two different voltage for AC and DC. Okay, we are having the plot in the next slide. We can, sir, you can go for next slide. Yeah. So this is the electrocution on human body as per the body current versus the duration of current flow in the human body. So the human body can feel the shock in the name of two parameter. One is called value of current, and along with the how long the current is taken by the human body. So it is the parameter between current and time. Okay, so this combination will create a electrocution to the human body. So we can see that the top representation of the plot is meant for AC. We can see that the let's go current is just 0.5 milliampere for AC. You can see here. Okay, so this is the let's go current. Let's go current is only 0.5 milliampere for AC. Meanwhile, we can come to the DC. We can go for up to 2 milliampere is the let's go. It is 4 times difference. Okay, so this is the reason the standards are recommending 30 volt and 60 volt for AC and DC. This is the reason for the disparity of the voltage classification for e-mobility. Okay, and also at what range humans are maybe collapse means we can see the red region on both cases for AC and DC. At AC 4.1, AC 4.2, AC 4.3. This all the three region is a very, very serious threat to the human body. While if you are going for the e-mobility applications, and also we are having the DC. We are having a DC 4.1, DC 4.2, DC 4.3. It's a three region. So all the three region is very, very threat to the human body, because this will lead to ventricular fibrillation and it will go for the total collapse of the human body also. This is the reason the voltages differ with the AC and the DC. So next slide, sir. So what is the claim? Why? How we are claiming this is the actual thing happening in the human body means? So one of the researcher called Charles Delsis. Okay, he was the pioneer for the electrocution on human body experiments. He did a wonderful experiment on human body by using both AC and DC. So he only suggested the let's go current and ventricular fibrillation scale and electrocution impact to the human body clearly to the society. Okay, that's why he is the pioneer for the electrocution on human body. Okay, and also why I'm saying AC is dangerous compared to DC for means, as I mentioned, because of the capacitive behavior. Because the capacitive behavior, AC will take a major role to trigger the more current from skin to the glands or cells to the human body. Okay, but we are having a additional discussion to represent the how the human get the electrocution means consists of purely resistance of the body, human body between right hand to leg, right hand to left hand, right hand to left leg, right hand to right leg. We're having a different resistance we can human body will offer. How the current is taking part, how is entering into the ground. So the current travel path is differ for human body. How we are going to connect with the electric circuits. If we are connecting the both hand in the electric circuit means the resistance of the human body is of course will be very, very severe. Okay, so there are the difference between where the current is injecting on the human body, as well as where the current is go out from the human body. So this will represent the total resistance of the human body. This total resistance will declare the let's go current, as I mentioned in the previous plot. So generally, sir, you can go for previous slide, sir. Previous slide. Yeah, of course. I think again go previous. Yes, of course. As I mentioned, the human body resistance is ranging from 500 to 1500 ohms. This is the actual body resistance offered by the human body. Okay, but where we can get the 500, where we can get the 1500 is there very, very complicated question, because it is depends upon the where the current is injecting on the human body and where the current is bypassing into the ground, either by left hand or right hand or left leg or right leg, depends upon the physical condition and the physical connection with the human body to the electric circuits. So these resistance will give the guidance what is the value of let's go current and what is the voltage required to trigger the let's go current. So next slide, sir. Again, sir, next, of course. So this is the experimental study given by the Dalsius research reports. So as you know, I think you are more aware about the body resistance between human and human. For example, men and women. The resistance of the woman is somewhat less only compared to the men. Okay, So that's why women can feel the shock very earlier compared to the men. As I mentioned, for example, for DC means as the let's go value is 2 milliampere. It's a general statement only, but that the current may decrease for the woman category because women consist of a low resistance compared to the men. So the let's go current is differ with human, for example, men and women also. This is a complete report given by the Dalsius research lab. It has happened 30-40 years back. Okay, so where the human get very severe threat to the electric current means from the current exceeding the 2750 milliampere. It's called 2.7 ampere. The current is 2.7 ampere. It injected into the human body means then we can say it is purely a process of human death. That may be a grid, that may be a battery current, whatever they think. Because I think you know about the current battery current. It is even if you go for low voltage electric vehicle, the current is of course 180 to 250 ampere. The help of 52 volt. So 52 volt, we are having the 250 ampere current. It is very, of course, somewhat dangerous only to the human body. I am talking only about the low voltage case. But if you go for high voltage case means, for example, Tesla using 800 volt as a voltage classification. It's a very high voltage for electric vehicle. So 800 volt is severely high voltage as current is also more than 300 ampere means think about the power. 800 volt into 250 ampere. It becomes a huge power delivered by the battery. If a human have a chance to connect or contact with the battery means or battery circuit, or if the fault happen in the battery, it inject into the body of the vehicle. If the human body touches with the body means how we can focus it. This is the major problem with electric vehicle and the safety. That's why I took the safety as a major parameter, major concern to my industry. Okay, so how we are going to restrict that, how we are going to protect the people or protect the rider and also service people and other technicians who are working in the vehicle servicing, and also fire people who are come into the rescue. If any accident happen, there are a lot of broad area we have to think about the safety concerns of the electric vehicle, and not about thinking about the chemical activity of the battery. I'm only thinking about electrical activity of the battery. Because chemical activities differ. We have a lot of safety precautions. This is totally different part. But I am talking only about the electrical threat to the human bodies in the meaning of electrocutions. So this is the complete report. So next slide, sir. Okay, I think it is. Okay, why we have to go for high voltage EV? What is the need? Since we have the low voltage vehicle consists of 52 volt. 52 volt is not enough voltage to trigger the current into the human body to make for electrocution. So we are in safe zone. Then what is the necessity for going for high voltage? This is one question. First thing is limitation on performance of low voltage EV. What the limitation of performance? For example, I have a vehicle called TVS Jupiter. It is scooter. We know that the maximum power of the Jupiter is 1 level. Okay, can I get the same performance in the TVS Apache? Not possible, because TVS Apache having a high performing vehicle or super premium vehicle. So here the performance is different. Okay, so performance of TVS Jupiter is different with the performance of TVS Apache because the power is different. Okay, if the people go with a low performance vehicle means they can go for TVS Jupiter. That's why we're having a TVS iQube. TVS iQube and TVS Jupiter are more or less same case, but one thing is Jupiter consists of IC engine and iQube consists of EV mode. Okay, but the performance you can relate it. But I'm going to develop the electric vehicle that should be having high performance like TVS Apache means what I can do? I have to go for high performance vehicle. But high performance vehicle, I cannot increase the current because current is limited to 250 ampere for low voltage systems. Okay, then 250 volt, 250 ampere as a current as a threshold means where I can go for the increase means of course I have to go for high voltage only because high voltage will increase the power. If I'm restricting the current value, that's why industries are looking on the high voltage vehicle development for future mobility. I'm only talking about two-wheelers. In four-wheelers, I think we are having a Hyundai, Mahindra, Tesla, and BYD. Okay, the lot of vehicles using the high voltage from 280 volt to 800 volt. There is no record in the any white papers of using more than 800 volt in e-mobility as on date. The maximum voltage offered by the maximum voltage used by the industries 800 volt only. It's a DC. Okay. So there is a need to go for high voltages because of considering the performance. Okay, that's why we have to think about the what is the limitation with the existing low voltage system. And what is the next advantage means we can go for low PWM frequency requirements, and also we can get lesser switching losses if you go for high voltage systems. Nowadays we are having the 1500 volt rating of controllers available in the markets. So we can go easily go for a high voltage system, because high voltage system for e-mobility control is the major concern. We already have 1500, 1700 volt capability of controllers in the market available. So we can go for. So because of that, we can go for very low PWM technology, and also we can prefer the low switching losses. And third category is a component cost and size. If you go with the high voltages with reduced current means, of course, it's a known thing only, because the cost is somewhat less, and also size will be somewhat less compared to the high current value vehicles. Of course, we are having a reduced heat loss and temperature, since we are reducing the current by increasing the voltage, so that the temperature rise in the battery, temperature rise in the converter, temperature rise in the motor is reduced drastically, and also the losses due to temperature, losses due to the heat. We have the advantages in technical parameters. And the fifth point, of course, by using the high voltage system, we can go with the reduced current, so that we can go for low power loss, because power loss is proportional to the current. If you reduce the current means, of course, we can go for low power loss. And enhanced charging speed. Of course, if you go for high voltage charging model means, reducing the current means, we can go for fast charging. Of course, fast charging is also a thrust area for recent scenarios. So if we go for the high voltage systems in e-mobility, we can go for fast charging very easily. But there are some glitches. Of course, we can overcome in the future technology, adopting future technology. Of course, next point is essential for high performance EV. As I mentioned, if I'm going to increase the power capacity of the vehicle, I have to go for high voltage only. No other option I have, because I cannot increase the current to some value because of the component size and the cost. There are some limitation with the standards. There are some problem with human interference with the vehicle. A lot of things we have to think about it. That's why we're having some restrictions on current usage in electric mobility. Okay. And finally, 8th point, reduce charging size. The charger, you can see the charger we are using for normal vehicle, low voltage vehicle. The size is about, the weight of the charger is about 37 kilogram. I can say that a small example for representation. A 350 volt 1000 ampere charger, the total mass is 37 kilogram. Just a representation. Okay, for the same power, I'm not changing the power. I'm going to increase the voltage for 800. So that current is decreased to 440. Now the mass of the charger is just 12 kg. It is applicable to the vehicle also. We can go for controllers. We can think about the motor sizing and some other cabling and circuit maintaining, everything. The size and mass will be reduced. Of course, size and the mass is one of the major parameter and electric vehicle range also, because even the 10 kilogram of reduction will increase the range of the vehicle. Okay, that's why the high voltage will also directly increase the range. Of course, the range is purely based on the battery, but if you go for high voltage means the range also can increase because of the reduced mass of components we are using in electric mobility. So these are the reasons why we have to go for high voltages for e-mobility. But final thing is, what is the problem with high voltage means the performance and the range can be enhanced to the required level optimally, but subject to the safety threats. Whatever the voltage I can increase, that is purely based on the technical and some other cost-effective things we are planning that. Then what about the safety to the humans? Safety, not only the riders. If the vehicle went for the crash, the first victim is the rider. So he is the first victim. Second victim, the person who came near to the vehicle to rescue the victim, he is a second participants in the victim. And third, a fire team, and follow with the service people in the service station. Okay, there are a lot of people are open to the electrocution threats because of the high voltage usage in the e-mobility. So then how we are going to resolve the problem with the safety if we go for the high voltage vehicle? I think we already seen a lot of examples, lot of white papers in the websites regarding the electrocution in the e-mobility if the vehicle is using higher voltages as per the standards. But research is also progressing how to restrict it, how to safeguard the people, how to safeguard the rider, how to safeguard the service people, how to safeguard the other people who is engaging with the vehicle in daily activity. So this is the major thing we are working on it. The next slide, sir. As I mentioned, we have a threats and demerits of using high voltages. First thing is arc generation will be increases because we are electrical engineer. We know that what is arc generation. Okay, if a voltage is increasing, of course the separation distance also should be increasing. If separation distance is increasing, means arc will be more. So we have to quench the arc. This is the major task, technical threat to the e-mobility because of using high voltage systems. So arc generation and arc quenching is the major concern in high voltage e-mobility. Okay, and follow with higher possible of life-threatening electrocution. As I mentioned in the previous slide, only 2 milliampere is more enough to feed the shock to the human body, and 200 milliampere is more enough to the ventricular fibrillation to the human body. But we're using a 300 ampere, 400 ampere with 600 volt, 800 volt, means this is the huge threat to the human body. This is the drawback this in terms of safety concern. Okay. So as I mentioned, we need special arc quenching technique during operation of the vehicle, but in switching between high voltage battery to the controller, high voltage battery to the motor, example I'm saying. Okay, so how we are going to quench the arc if the arc is severely high because of increased voltages in the system. Then leakage currents. If the voltage is more, means leakage current also more. Where the current is leakage? Current can leakage from high voltage battery to the body of the vehicle. The body of the vehicle is openly we can touch to any human. Okay, so if the voltage is increasing, means leakage current from circuit to body is increases. The same leakage current exceed 200 milliampere, means human can be victim. So leakage current also one of the major problem because chassis is full of metal parts. So that if the chassis take over that leakage current, then again we are the problem. So we will be the victim for that. Okay, and fifth is problem with the insulation coordination, insulation thickness. I'm using 52 volt, means the insulation level is somewhat less. I'm going to use for 800 volt, means the insulation thickness should be 20 times more. So how I'm going to handle the insulation thickness and insulation coordination of using high voltage vehicles or high voltage mobility? This is also major problem, insulation problem. Okay, and also if insulation failed, means there is a lot of chance for the electrocution to the human body, because 800 volt example I'm saying with the help of 400 ampere of current. So if the 400 ampere of current is pushed by this 800 volt voltage, means it's very, very serious threat to the human body. So insulation failure is one of the main concern in the high voltage vehicles. And lack of safety standards. There are very less white papers and recommendations are still available regarding the safety concerns of electric vehicles. Till date, there is no data is available how the electric current will take over the human body in e-mobility cases. We are still referring the conventional electric system only. There is no specific study or specific standards are available to study the behavior of battery current, battery voltage into the human body. So this is also one of the threat. We are also having a demerits. And next is a potential equalization. So I think you're not aware about potential equalization. This is also one of the dangerous part in electric vehicle. For example, I have a battery at one area of the vehicle, and other side I'm having the motor. Okay, so battery is placed on the metal part of the vehicle only. Also, the motor also placed on the metal part of the vehicle. Both are placed in the body. But if there is a difference in the resistance between the body which placed the battery and motor, the resistance is varies means voltage also varies in the ground potential or the vehicle chassis potential. If the voltage difference is taken place between battery grounding and motor grounding means we are having a potential difference on both places. If any, because the problem is vehicle is in within 2.5 meter only. If a person, if a serviceman touches the both grounding, battery grounding and motor grounding at the same time means, if the voltage is not equal between the motor grounding and the vehicle battery grounding means there will be a potential difference. This potential difference will inject a huge current on the human body, because the potential difference means there will be some voltage. That voltage will push the electric current to the human body. So how to equalize the potential between the groundings? This is called a potential equalization. For example, I am saying this a power system means the sending end is and the receiving end is very far. People cannot touch both at the same time. So we don't think about the potential equalization. But in vehicle, it's very close proximity. Within few feet, we are having two different potential possibility. The potential difference is more between the two grounding, then there is a serious threat to the human body. That is called a potential equalization. So research is also going on the potential equalization, how we are going to decrease the potential differences between the grounding of motor, controller, and cooling systems and batteries, etc. So there are some industries are using some conductor to make the equal potential on the all part of the grounding body. There will be a separate topic. Okay, so these are the threats and demerits of high voltage systems using in the electric vehicle. So next slide, sir. Yes. So where we are at present, where the Indian manufacturers are still working means the maximum voltage used by the two-wheeler, and when talking about two-wheelers, okay, it's 72 volt by Ola. So this is the maximum voltage by two-wheeler. Okay, but research that means there are some projects under pipeline to go for 110 voltage also by few industry, but that can be revealed at this situation. That depends upon the internal policy. So Bajaj, Ather, Hero, TVS, Ampere, Ola, they're using the voltage from 51.1 volt to 72 volt as the maximum. Okay. So among these, which is the highest? I mean, 72 volt is the highest, because as per the standard, 72 volt is a higher voltage or high voltage. Okay. But what is the global condition? Sir, next slide, sir. So this is the global scenario. Okay. We are having a lot of global manufacturers, start from Energica, Zero, Harley, BMW, Vector, Ducati. We can see that I mentioned earlier, Tesla four-wheeler uses 800 volt. That is not a wonder. Okay, but the Ducati two-wheeler is using 800 volt. This is a wonder. Okay, because how the 800 volt can be managed by the Ducati manufacturer? This is a very, very serious task. Okay. But there are the problem how these vehicles can be commercially applicable to the people. For example, if it is if the vehicle is used for only for racing means, of course it is applicable. But how this 800 volt vehicle can be applicable for the market? There will be some problem with the safety concern. Okay, but they are looking on the performance on the track, not on the road. That's why they're going for very serious voltages. Again, I'm saying why they're going for higher voltage means because of the performance enhancement. Okay, so these are the thing. Even the BMW also using 148 volts. Okay, and Energica 306 volts. Zero using 102 volts. Harley using 400 volts. Vector using 399 volts. Ducati using 800 volts. This is only for two-wheeler manufacturer. I'm saying that. And if you're talking about the four-wheeler manufacturer means Hyundai, Mahindra are using close to 400 volt. Okay, Indian manufacturers are limited to voltage application up to 400 volt only, but Tesla, BYD using more than 400 volt also. So as per my knowledge, Tesla using 800 volt DC. So next slide, sir. So as in, I need to convey the balance between high voltage benefit and penalty or the safety threats. There is a one important term called identity factor. This has been represented with the help of TRIS. I think you know about TRIS model. Okay, so TRIS model represents identity factor. This is the ratio between benefits and the penalty. So our benefit is high voltage because they're having a lot of benefits of using high voltages. And other side is we're having a lot of problem with the safety concerns, threats. So though ideality factor is nothing but it is a ratio between benefit and the penalty. Penalty is a problem. Benefit is the advancements. That's why we're going for high voltages. Then how we are going to get the optimized solution? So we have to apply some optimized model, optimized method, optimized technique to increase the benefits of the high voltages and decrease the threats of the high voltage system. This is the major thing we have to think, we have to process for the future scope of the research and validation. Okay, so increasing of benefits as well as decreasing of penalty is the major task for the researchers of the future to make the sustainability of the electric vehicle for the high voltage systems. So next slide, sir. So where we have to work on to this technology to enhance the high voltage system means we are classifying into 5 categories. One is HV charging system, followed with the HV battery pack and the BMS, followed with the HV power controllers, HV motor drive and software. Of course, software plays a significant role because the software can assess the insulation characteristic behavior. It also software can compute the short circuit from the electric battery to the body or some other components. And leakage currents, because software plays a major role in electric vehicle because they are the informers to the humans or users and also service people. Okay, so before any problem taking place in the vehicle, the software indicates in the cluster. Because as you know, cluster will display everything to the humans. Okay, so this software, the cluster is purely with the backend of software only. Okay, so the softwares also should be enhanced for the high voltage applications. Okay. So for a FV charging system, we are thinking about a serial configuration, adaptive charging system, ultra fast charging, insulation characteristics, leakage characteristics. These are the HV charging system sub areas, and also subsystem for HV battery pack and BMS is chemistry of battery. How the high voltage affect the chemistry of the battery. How we can enhance the chemistry of the battery for high voltage application. These are the research area. Okay, and protection of HV battery. Since we are going for higher voltages of 800 volt. How we are going to give the protection to the battery in terms of mechanical as well as electrical stress to the battery packs, and fault study of the battery, because 800 volt 300 500 ampere is the huge power capability battery. How we are going to study the fault behavior of the battery. Okay, and cooling system cooling system of the battery, and as I mentioned, insulation behavior of the battery, and arc quenching and the phenomena, because battery is the source of the entire vehicle. So battery consists of the contactor, battery consists of the service lock switch, battery consists of BMS. So there will be a switching operation taken place between battery and the controller. So how we are going to quench the arc during switching operation of the battery. And finally, leakage current of the battery. And HV power controllers, we can go for high voltage IGBT switching schemes, reactive power management if you're going for AC blended with the DC, an harmonic study of the inverters, insulation behavior, and again leakage current. These are subsystem research area for HV power controllers. Sorry. And I come to HV motor drive. Since if you go for AC drive means we are using a PMSM design. Of course, we are thinking about how we are going to design the PMSM for high voltage system, how we can control the torque, voltage, and current for the high voltage system. Again, short circuit of the high voltage motor, again insulation behavior of the high voltage motor. Since we are using more voltage means insulation of the armature coil and etc will be very different compared to the low voltage systems. Okay, so we have to go for some modification of using high voltage system for a motor design also, and of course end with the software system. So these are the technologies we have to bridge to make a one design of one compact vehicle. Okay, it's not a pure one technology we have to adopt, starting from charging system, battery management, battery pack, HV controllers, HV motor drive, and software and embedded system. So all this become a one vehicle. I'm talking only about the powertrain. I'm not talking about the vehicle dynamics and some other parameters. For the development of powertrain alone, we need to think about this kind of technology, this kind of subsystems. We have to work on it to get the good knowledge on electric vehicle for high voltage applications. So next slide, sir. I think we're close to the session, of course. So how we can mitigate at the present stage means we have to provide proper training to the target people. Target people is differ here because If I am an engineer to develop that e-vehicle means I am also target because I also victim at one situation. Okay, so the design engineer, okay, and assembly people, okay, logistic people, service people, customer, fire restricting people. So all the people are here to become a one area on the safety concern. Okay, so there are the training things happening globally to operate the vehicle at the different stages. Okay, so generally the training can be classified into four category: S, 1S, 2S, 3S. 1S, sorry, before 1S, they're having a S called operation of vehicle. Generally, the consumers. A consumer is nothing but a rider, a person who purchased the vehicle and driving the vehicle for a long time. They have to undergo the training called training S. Then follow with 1S. The 1S people is nothing but general work on the vehicle. For example, if your vehicle went for crash, there is a problem with the body, there is a problem with the wheel, there is a problem on motor. Okay, so the general vehicle service people who take the paintings, who taking the steering control, controlling erroring, who take place tire changing, these people comes into 1S category. Okay, they undergo the training called 1S to work on the electric vehicle high voltage system. Okay, and 2S is the people who are closely working with high voltage components, batteries, motors, controllers, cooling system. The people who is closely working on that high voltage system, but not in real time. That means the high voltage system is switched off. So in real time, they are not working, but they're working on high voltage systems. This is called 2S. Who is called 3S training means troubleshooting people. The people can have the capacity to work on live system. That means battery is on, motor is on, everything is on. So for the live system, the people have the potential to work on the vehicle to troubleshoot the vehicle if any problem happen to the in the system on the vehicle. So these are the four classifications of training is globally recognized by the standards. In future, all the training should be given to the consumers who is purchasing the vehicle also, because they need to know about what is high voltage. They need to know about what will happen if any crash taken place. They need to know if the vehicle is went for a wet area. If the vehicle suddenly went for flood means what to happen? There's possible electrocution. So there are some basic awareness we have to give to the consumers also to safeguard themselves. So these are the trainings globally. The recognitions, globally the some industries are taking place. In future, not in future, in some country called I can say about Singapore. If you prefer to go with buying of electric vehicle in high voltage means you have to undergo one training. Then only you can purchase the vehicle. It is already available in some country, but in India there's no protocols we are following now. But in future this may be possible because still in India we're using lesser voltage only for two-wheelers and also for four-wheelers. If you go for the 800 volt or 1000 volt, it means of course then we have to think about the safety precautions and training modules for also consumers and also service people who is working on the dealership, etc., etc. Okay. So these are the final thing I wish to tell you. So in future, any part of the high voltage e-mobility engagement with the human, they have to perform the training. Otherwise, you can't assess the electric vehicle in the future. I think so. Next slide, sir. I think we are the end. Of course. So thank you. Thanks for the good session given to me. So I need to thank Dr. Ajay Venkatesh. Actually, the thing is, morning 10:30 only he called me, sir. So kindly give one session, sir. So I took the session as per my availability of the.
Sir, thank you very much, sir. That resource person, due to medical issue, is gone out. That's why, but you are given very good presentation, sir.
But if you give at least say night means I will make a good presentation compared to today.
Oh no, sir, it's nice presentation, really wonderful presentation, sir.
Yeah, of course. If any clarification, also we can make it now.
Participants, please, if you have any doubt, ask to Kannada, sir. Any clarification related to HEV safety?
Participants, if you have any doubts, if you need any clarifications, you may unmute your mic and you may raise your questions too, sir. Any questions from participants? Any doubts? Sir, myself, I have one small question, sir.
Yeah,
Can I
please.
proceed, sir?
Sure.
Sure. So thank you, sir. Sir, actually, your presentation was very nice, sir. So I have one doubt in that voltage regarding the voltage consumption, sir. Actually, you said that maximum 800 voltage is nowadays applicable because the companies they are reaching about 800 voltage. Beyond that, there is no report or any results are there. You said, sir. Sir, what about the heavy vehicles, sir, like electric bus and some other heavy vehicles? How much voltage they are designing, sir?
They are also still under the 800 volt only.
So still they are in under 800. Okay, sir.
Yeah.
So it is sufficient for operating all these things present in the electric vehicles, sir.
Yes, including the commercial vehicle also, I can say that the maximum volt is 800 volt as per the record availability.
Okay, sir. Thank you, sir. Thank you, sir.
Okay.
So participants, if you have any doubts, you may ask.
I think no doubts
You
from-
post your questions in post box, chat box. Use chat box and raise your queries.
I think they don't have any clarification on this presentation.
Sir, you are given nice presentation. That's why no doubt, sir.
So this way also we can.
Sir. Excellent, sir. Excellent, sir.
Thank you very much. Sir.
Thank you, sir.
Venkatesh,
Thank
sir,
you.
shall we close the session, sir?
Yes, sir. Okay, sir.
Thank you.
Thank you,
Thank
sir.
you.
So,
Thank
good
you.
afternoon, everyone. So, we wrap up this insightful session on advanced battery design for EV and ESS application. It is my privilege to extend our heartfelt gratitude to our esteemed resource person, Dr. R. Kannadasan. Sir, your session has given us a deeper understanding of high voltage safety and advancements in energy storage systems. Your vast experience in industry and research has made this session both informative as well as engaging. So the way you explained a complex concepts such as the importance of AC and DC voltages in EVs, essential for high performance EVs, threats and demerits of high voltage in EV are very clear and practical manner, which has truly enriched our learning experience. On behalf of SRM Madurai College for Engineering and Technology and the Atal FDP organizing team, we sincerely appreciate at the time and effort you decided to this session. Your expertise and contributions to electric vehicles, power systems, and smart technologies are truly inspiring, and we are grateful for the opportunity to learn from you. A big thanks to all the participants for your interest and active engagement throughout the session. Your curiosity and interaction have made this discussion even more meaningful. So once again, thank you, Kannadasan sir, for sharing your knowledge with us today. We look forward to more insightful session in these coming days. Thank you, sir. So before we conclude the sessions, participants are requested to fill the feedback form already, which is posted in the comment box. Thank you, sir.
Thank you, Anbarish and Dr. R.J. Venkatesh for the.
Thank you, Kannadasan sir. Kindly visit SRM Madurai, sir, in future. Come and give your physical presentation.